Hello everyone, happy to see you here. Welcome back to my channel. Hi, I'm Mathematics. Today we have a very interesting cubic equation, a cube plus 5a equal to 42, and we need to find our a. If you have your answer, your assumption, you can also write your solution down into the comment section, and then we will check our answers. Okay, so what are we going to do at first? We're going to write this 42 on the left side. As a result, what do we have? A cube plus 5a minus 42 is equal to 0. Right now, this 42 can be written as 27 plus 15. Right now, let's write this instead of this 42. Let's write, so in the beginning, a cube plus 5a, but instead of this 42, let's write 27 plus 15. Okay, 27 plus 15 is equal to 0. Right now, let's open our parentheses. So as you can see right here, I just write this instead of this 42, 27 plus 15, so everything is great. Right now, let's open parentheses real quick. So as a result, we have a cube plus 5a minus 27 and minus 15 is equal to 0. Right now, let's group, okay, because 27 is equal to 3 cubes. So instead of this 27, we can write, so this is equal to 3 times 3 times 3. This is equal to 3 cubes. So instead of this 27 right here, let's write 3 cube, and then we can easily group this 3 cube with the a cube, okay? Let's do this right now. So we have a cube plus 5a minus 3 cube and minus 15. Is equal to 0. Right now, let's group this a cube with this 3 cube. Okay, let's group it. As a result, what do we have? We have a cube minus 3 cube. This is our looks like our first parenthesis, and as a result, we have 5a minus 15. So plus 5a minus 15. Is equal to 0. Right now, if you look closely, we have a cube minus b cube. So this is our difference of 2 cubes. And we need to know by formula. This is our all-known school formula. We have a cube minus b cube. Is equal to a minus b times parentheses. We're going to have a squared plus ab, and plus b squared. So right now, let's apply this formula in this parenthesis. So we have difference of 2 cubes, a cube minus b cube. Let's apply this identity. Let's apply this, sorry. Yeah, so we have a minus b, so we have a minus 3. And in the second parenthesis, we have a squared plus 3a and plus 9. But one really important moment. So we, as you can see, we write this difference of 2 cubes according to formula. But at this moment, we can easily factor our 5. When we factor 5, so we have plus 5, and in parentheses, we're going to have a minus 3. Okay, a minus 3. Okay, equal to 0. And if you look closely, right now we have a minus 3 and we have a minus 3. So we can easily factor our a minus 3 as a common. So let's do this right now. So we have a minus 3 in the beginning, so a minus 3. And in another parentheses, what do we have right here? We have this expression, and we have only 5, okay? So we have a squared plus 3a plus 9. This is our first parenthesis, and we have plus 5 from here, equal to 0. We can easily find it, we can easily add it real quick, because 9 plus 5 equal to 14. So as a result, our expression looks like that: a minus 3, first of all, and second expression, a squared plus 3a, and we have right here plus 9 plus 5 equal to 14. So plus 14 equal to 0. So as you can see, we factor our equation, and it's really great because right now we can easily solve it, because we have a product of 2 parentheses equal to 0 and a product of 2 parentheses equal to 0 when the first parenthesis is equal to 0. So when a minus 3 is equal to 0, or this one equal to 0, a squared plus 3a and plus 14 is equal to 0. So let's start, for example, with the first equation, a minus 3 equal to 0. From here, our a first is equal to 3. We're going to check this root a little bit later. So we have a first equal to 3. And let's solve our second. This is a quadratic equation, so let's solve it with the basic method, because this is up to you. You can solve this question whatever you want. I want to solve it with the classic method, with the coefficients. So we have a equal to 1, b equal to 3, and c equal to 14. C equal to 14. Let's plug in each of these elements into, first of all, let's find discriminant, and then we're going to plug in this discriminant into the other spot. Okay, so discriminant equal to b squared minus 4ac equal to, we have b squared, 3 squared, minus 4 times a times 1 times c times 14. So our discriminant is equal to 9 minus 4 times 14 equal to 56. Okay, equal to 56. So our discriminant is equal to minus, what do we have right here? Minus 47, yeah? Minus 47. And it means that in this case, we have two complex roots because discriminant is less than 0. So at this moment, we're going to have two complex roots. Let's find it real quick. So a second and third is equal to minus b plus minus square root of discriminant and all over to a. So let's plug in each of these elements into this spot. We know everything about it. So in our case, we have minus b minus 3 plus minus square root of discriminant, square root of minus 47. And we divide it by 2 times 1, 2 times 1. Let's simplify this real quick because we have minus 40 square root of minus 47, and in terms of real numbers, this expression does not exist. But we can easily write it as, so minus 3 in the beginning, plus minus, we can easily write it as square root of minus 1 times 47. Okay, we can easily split it, yeah, and over 2. So according to a basic property, with the square root, we can easily split it like, because we have a square root of a times b, we can write it as square root of a times square root of b. We can easily split it, and right now let's do this. So as a result, we have minus 3 plus minus square root of minus 1 times square root of 47 all over 2. Square root of minus 1 equal to I. This is our complex unit, so we have minus 3 plus minus I square root of 47 all over 2. And of course, this is our answer, but in our case, we can easily split it by a real part, an imaginary part, sorry. Yeah? We can write it as minus 3 half. We can easily divide it by 2. So minus 3 half plus minus I square root of 47 over 2. So this is our real part. This is our imaginary part. This is up to you. How do you learn this part with the discriminant? I prefer this one. We have real part and we have imaginary part. So these are our two roots. Of course, right now let's write our final answer, and then we will check real quick our a equal to 3. Right now we can see a graph. You can look at this from geometric perspective. So our answer to this question, our answer, a first equal to 3, a first equal to 3. This is our one real number root, and we have two complex roots. The first one, so let's write with the positive sign, so minus 3 half plus I square root of 47 over 2. And the third one, so a third equal to minus 3 half minus I square root of 47 over 2. So this is this one is real number root, and these two roots are complex roots. So we have our answer, real number root and complex number root. And in the end, I'm going to check real quick our a first equal to 3. So let's write it, let's prove it, let's check it. So check. Our equation looks like that, a cubed plus 5a equal to 42. Let's check real quick our a first equal to 3. So a first equal to 3. As a result, what do we have? We have 3 cubed plus 5 times 3 equal to 42. So 3 cubed equal to 27, of course. Yeah, we have 27 plus 5 times 3 equal to 15, equal to 42. And we have 27 plus 15 equal to 42. So 42 equal to 42. So our left-hand side equal to right-hand side. Right-hand side, so it means that our root is great. Our root is absolutely correct in our question. So this is my solution to this question. I really hope you understand it. So in my opinion, this is not the hard question. This is a basic cubic equation, but with the really important tricks right here, because we write, instead of this 42, we write 27 plus 15, because 27 can be written as 3 cubed, and then we can group it with the a cube. This tricks helps us a lot, because without this trick, you can easily, not like easily, you will solve this question with the Cardano formulas, and Cardano formulas, it's like more complicated thing. I'm not gonna lie, you spend like 2 times a lot of time to solve this question with the Cardano formulas. But with its interpretation, with the with this trick, you can easily solve this question without any problems, because with Cardano formulas you're going to solve this question a little bit longer than this solution. In my case, I solved this question like that. So I really hope you understand it. I really hope you enjoy it. You can also write your thoughts, write your notes down into the comment section. It's really interesting to exchange information. Also want to say thank you, Aaron, for watching my my videos. I posted more like than 500 videos, so it's really great that you're watching my channel, and I try my best to make new content every day, to make new videos every day. So I really hope you enjoy it, and I really hope you support me with this content. So thank you everyone for your time. Wish you all the best in your life. Take care of yourself. Write your notes, write your response down into the comment section, and then we will discuss a little bit about it, because math is really interesting science. And thank you everyone for your time. Wish you all the best in your life. Take care of yourself. Have a great day.